Assalamualaikum warahmatullahi wabarakatuh. I'll be to our lecturer, Mr. Muhammad Mazwan bin Mahat. Today, our group, represented by Muhammad Shakirin, Muhammad Ikhwan, Muhammad Al-Hazim, Muhammad Nabil, and Muhammad Hazman Ahza, will be presenting on our chosen company, which is Tupperware brand. Hello, I am Muhammad Hazman Ahza bin Nurizal, and I will be presenting on the history of Tupperware. On the top left side of the slide, we can see Earl Tupper. Earl Tupper is the founder of the Tupperware brand back in 1946. He was a chemist and started with creating a lightweight, non-breakable plastic containers, which is inspired by the seal-tight design of the paint cans. However, at first, Tupperware products didn't sell well in the store. This is due to the innovative designs that the customers needed demonstration to understand how they works. This is where Brownie Wise played a major role in marketing the Tupperware brand. In 1950s, under her leadership, Tupperware brand became well known for offering American women opportunities to earn more, draft their careers, and increase their confidence through building success on their own terms, where she asked the American woman to demonstrate on how to use the Tupperware. And now we can see the impact where almost all households have a Tupperware brand item in it. Products of Tupperware. As we can see, there were variety of products under the Tupperware brand. In early stage, the food container was used in the World War II, and then after that, it became well known in America. This is when Brownie Wise saw the potential of this brand going big, and they started to introduce other kitchen essentials aside from food container. They are not just kitchen essentials, they also sell air purifier and even toys.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Al-Hazim bin Shamudin. My matrix number is 2020-859854. Today I will present about the manufacturing process. So basically, manufacturing is the production of goods through the use of labor, machinery, tools, and biological or chemical processing or formulation. Manufacturing can either mean transformation of raw material into finished good on a large scale. It also can mean about the creation of more complex items by selling the basic goods to the manufacturer for the production. So in this topic, we will highlight about the Tupperware. So the manufacturing process that we highlighted is molding process. So molding is a manufacturing process that involves shaping a liquid or malleable raw material by using a fixed frame. Uh, the mold is generally a whole cavity receptacle, commonly made from metal, where the liquid plastic, metal, ceramic, and glasses material is poured into the mold. So basically, in mold process, there are some methods, which is extrusion, injection, blow molding, stretch blow molding, injection molding, and lastly, multi-layer co-extrusion. So the first one is extrusion blow. So basically, extrusion blow molding is the process is the plastic will melt and extrude into a hollow tube and form a mold. And the main part that must be highlighted is present. Present is held and still in the metal mold. So the example product that has been made from this process is plastic bottle. So basically this is a process procedure which is 6 step, and this is the example machine. Next, injection blow molding. So injection blow molding is a method of manufacturing products and parts by injecting materials such as a plastic into a mold. So plastic in the form of pellet is melt and then injected into a mold. So basically, injection blow molding is similar like extrude blow molding. So the example product also plastic bottle. So this is the process procedure and example machine. So next, stretch blow. So stretch blow is used either the injection or extrusion blow molding process as a basic foundation. A preformed partition is molded and then transferred into a blow molding cavity. The partition is stretched visually during the blow molding to orient and align the molecule. So example product that can be made from this process is carbonate beverage container. So this is the process procedure and example machine. What we can see the process procedure is similar like extrusion and injection molding. Alright, next the injection molding. So injection molding is a method to obtain mold product by injecting plastic materials molten by heat into a mold. It's suitable for mass production, like it has a complicated shape. So basically, injection molding has two units. For the first is clamping unit, and the second one is injection unit. So example product in this process that have been made is plastic chair, Tupperware, plastic bottles, and plastic stuff like spoon, fork, plate, and others. So this is the process procedure and example machine. So this the last one is multi-layer co-extrusion. So this process is a new latest technology that has been a revolution from the others. So this process is two or more polymer are extruded and joined. The technology of making hollow container by blowing molding. It used then two extruder to melt and plasticize the same of different plastic in different extruder. So the product that has been made from this process is multi-layer, brown film, tubing, wiring, and profile. So this is the process procedure and example machine. So basically, for the conclusion from manufacturing process, we can see injection molding is the good or the suitable process that we should use in making the Tupperware. So before I ending my presentation, uh, this is the comparison regarding the all molding process. So each process have pro and cons, but we as a future engineer must know the pro and cons. So we will get ready about the product that we want to make it. So thank you from me. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikwan bin Muhammad Zamri, and I will continue with the problem that faced by the Tupperware company. Defect, which is a defect that can occur in the manufacturing process, which is injection molding. So the first defect is warping. Warping is a deformation that can occur in the injection molded product when different part of the component shrink unevenly. So the cause of the warping is the cooling happen too quickly and excessive temperature or low thermal conductivity of the molten material. So the common way to prevent the warping is by ensuring the cooling process is gradual and long enough to prevent uneven stress on the material. Next is lower the temperature of the material or mold. Last, redesign the mold with uniform wall thickness and part symmetry to ensure greater stability in the part during the cooling. So the next defect is seam mark. Seam mark are depression in flat and consistent surface of the molded part that occur when the inner part of the molded component shrink from outside inward. So the main cause of the molded part is the material cools too slowly, and shrinkage pulled the outside material inward before it had a chance to adequately cool. So the best way to prevent seam mark is by increase the holding pressure and time to allow the material near the part surface to cool. Next is increase cooling time to limit shrinkage. Lastly is design mold with thinner component wall to allow for faster cooling near the surface. The third defect is flash. Flash is an excess of molding material that appear as a thin lip at the edge of the component that appear due to material has flow outside of the unintended flow channel. So the cause of the flash is a poorly designed or worn and degraded mold. Next is excessively high mold temperature or injection pressure. So how to prevent the flash is by retool or redesign the mold if plate do not fit together properly or allow material to flow outside the channel. Increase plate clamping force to confine material flow to the channel. Lastly, adjust mold temperature, injection pressure, and ventilation to improve material flow. Next is delamination, which is a thin layer on the surface of the molded part that are easily separating or peeling off the underlying material. So the cause of the delamination is flaky separation result when the two material cannot properly bond to each other. Next is excess moisture on the material due to improper drying prior to use can also cause the delamination. So the best way to prevent delamination is by increase the mold temperature or pre-dry the material properly if excess moisture is an issue. So next is ensure workers are properly storing and handling the resin pellet or base material to prevent contamination. Lastly, consider redesigning the mold if focus on the injection nozzle to limit your dependent or release agent. The last defect that can occur during the injection molding is vacuum void. Vacuum void is a trapped air bubble that appear in the finished molded component. So the main cause of the vacuum void is inadequate molding pressure to force trapped air out of the mold cavity. The material may be vulnerable to void if the density change significantly from the molten to hardened state. So the best way to prevent the vacuum void is by raise the injection pressure to force out the trapped air bubble. Next is choose a grade of material with lower viscosity to limit the risk of air bubble forming. So the lastly, place gate close to the thickest part of the mold to prevent premature cooling where the material is most vulnerable to void. And the other problem that faced by Tupperware company is the customer did not know the requirement for warranty. Tupperware brands guarantee that all products are bound to receive a replacement if damaged under domestic circumstance and non-commercial use. So the warranty is given against chipping that may occur along the edge of the product, breaking that produce hole in the product, warping, and cracking that can be large or tiny. And the warranty become void due to stain, which is not affect the performance of the product, scratch from the normal use, cut or chewing by other sharp object, and lastly, the microwave damage due to food with high in sugar and fat, but still didn't affect the performance. So that's all from me. Thank you.
My name is Muhammad Sakirin bin Saudi. I will present about design concept and quality assurance. The slim lunch container is the ideal solution to take raw or cooked food on the go. Thanks to its sleek design, it fits in backpacks, picnic coolers, and even handbags. With 2 compartments, 2 meals can be transported separately. Another small container with an air and watertight closure, it makes even the transport of sauce possible and fits accurately in the smaller compartment. The container can easily be opened with tabs which are positioned at the seats and the container itself. This model achieves a partial vacuum seal, important for keeping food fresh. Trusted for generation and designed for everyday use, Tupperware products have passed stringent tests and are built to last. They are quality products that are food grade safe, which is integral to family health. They are also designed to be used repeatedly, thus reducing unwanted mountain of garbage. World standard. To begin with, all Tupperware products are made from safe, non-toxic, non-carcinogenic materials. Thus, they do not release harmful chemicals to food or liquid contents. Material and additives used exceed US Food and Drug Administration (FDA) and Japan Polyolefin Hygienic Association standards. JPHA contribute widely to the safety of PVC products from viewpoint of food hygiene, with continued activities up to now. What it means is that you can use the product with peace of mind. The next quality assurance is color safe. One will release the attractiveness of Tupperware merchandise in fabulous stylish colors and be assured that the colorants used are all registered on the French positive list, circular letter number 176, which is the most stringent in the world. It published a list of colorants that can be used for the coloration of food packaging in France, and also complies with Council of Europe Committee of Ministers Resolution AP 89 one requirement, which indicate that the colorants used in the products will not transmit any of their elements to food in quantities that could be harmful to human health. The top quality and finishing is the biggest flag for this product quality assurance. All products have passed stringent tests and are built to last. Its design and smooth finishing make Tupperware products a delight to hold and use for any occasion. The high quality and standards are reflected in its typical single product mold. Another pertinent quality assurance is its innovative design. Tupperware products are designed to inspire. Unlike ordinary plastic products, many Tupperware products have won worldwide awards such as Industrial Design Excellence Award, Red Dot Award, IF Seal Award, and numerous others. All these awards acknowledge Tupperware as products that combine dazzling beauty and exceptional functionality. Indeed, one can use Tupperware with pride. Microwave safe, where Tupperware products are indicated for microwave use. The Tupperware's microwave safe storage boxes are all safe for reheating and won't warp or melt. Tupperware use materials strictly meant for microwave use and adhere. Lastly, environment friendly is definitely the major quality assurance for the product. Tupperware played its role in saving Mother Earth from further pollution and degradation, as its products are designed for long-term use. On the other hand, plastic bags and bottles, styrofoam containers and PET bottles are not meant for repeated use, and thus add to the mountain of garbage. Tupperware products can reduce wastage as it can be used repeatedly.
Assalamualaikum. My name is Muhammad Nabil Birja. I will now be presenting the material commonly used by this company in making the product. There are a few materials used during the production of the product, such as low-density polyethylene (LDPE), polypropylene (PP), high-density polyethylene (HDPE), and polyethylene terephthalate (PET). These materials are chosen based on their characteristics. First is low-density polyethylene (LDPE). It's a soft, flexible, lightweight plastic material. LDPE is known for its low temperature flexibility, toughness, and corrosion resistance. Then polypropylene (PP). PP has high flexural strength due to its semi-crystalline nature, has a relatively slippery surface, very resistant to absorbing moisture, and has good chemical resistance over a wide range of base and acid. Next is HDPE. HDPE is known as flexible, translucent, weatherproof, good low temperature toughness 0 to 60 degrees Celsius, easy to process by most methods, low cost and good chemical resistance. Lastly is PET. PET known for its transmissivity, shatterproof, strength to weight ratio, and chemical resistance. But most Tupperware plastic products are made using two materials, which is low density polyethylene (LDPE) and polypropylene (PP), because these two materials are considered as safe for repeated use storing food items and cycling through a dishwasher. There are many different processes for manufacturing plastic, such as injection molding, extrusion plastic, and blow molding. What are the fundamental distinctions between the various plastic production processes? Here is an example of quick comparison. For injection molding, the plastic polymer is fed into a heated barrel and screwed through a hooper. The screw melts the plastic and inject the liquid polymer into a temperature-controlled split mold tool, which form the product shape. And for plastic extrusion, plastic powder or pellet are fed into the extrusion machine via a hooper during the extrusion process. A screw pushes molten plastic through a metal die, which is then cooled to give the plastic a fixed, continuous shape while being continually pushed and molded into the final shape, while the polymer is heated within a barrel at the controlled temperature. And for blow molding, air pressure drives the hollow plastic to expand into the mold or extrusion shape, leaving the interior of the product hollow, similar to the plastic extrusion and injection molding process. Injection molding prototypes are both an art and a science to create. When it comes to mass production of unique parts, high level of technical competence and attention to detail are necessary to avoid little mistake costing company a lot of money. High quality design is essential for avoiding such a situation. Here is a few prevention for company to minimize the losses due to defect of the product. For flow line, increase injection speed and pressure to the optimal level, which will ensure the cavities are filled properly while not allowing the molten plastic time to start cooling in the wrong spot. The temperature of the molten plastic or a mold itself can also be elevated to ensure the plastic does not cool down sufficiently to cause the defect. For seam mark, mold temperature should be lowered, holding pressure increased, and holding time prolonged to allow for more adequate cooling and curing. For vacuum void, locate the gate at the thickest part of the molding. For burn mark, reduce injection speed and optimize gas venting and degassing. For wet line, raise the temperature of the mold or molten plastic and increase the injection speed. For flash, increase the clamp pressure to ensure that mold part remains shut during shots. Lastly, for surface delamination, pre-dry the plastic properly before molding and increase the mold temperature. Thank you. That's all from me.